Oh, nice. I'm really glad that that's the case.
Yeah, it is kind of nice.
Okay, we're about 5 minutes in, so I'll get like the official event started and kind of introduce what we're going to be doing today. So thanks everyone that's joining kind of live on the Zoom call. This event's going to be recorded and posted on our YouTube channel later. So thank you to all those who are watching this event back as well. So my name is Morgan. I'm here on behalf of New England Graduate Women in Science and Engineering. I'm one of the directors of the organization, and we are essentially an alliance of different graduate women in STEM groups across New England that was formed in 2017. And so there's currently one founding member that's still in the organization, which is really, really awesome. So I'm a graduate student at Dartmouth, and I think everyone here is affiliated with Dartmouth, which is great. So the New England Consortium includes Dartmouth. We're also affiliated with various schools in the greater Boston area. We're affiliated with Brown in Rhode Island and looking to expand every single year. So hopefully we'll keep growing and building the community of graduate women in STEM groups. And we're currently kind of allied across common issues, the main one being we're seeking to create more equitable gender representation in science. And so the New England GWiSE organization seeks to do this through various advocacy efforts and holding events. The format of these events has changed slightly since 2020, obviously, but it's been really great to hold the virtual events that we have had, one of those being a virtual series that we held every month in the 2020 to 2021 year. But it's been really great to grow the community of graduate students and in STEM and early career professionals in STEM through having these virtual events and virtual meetings, especially coming from this rural graduate school, in New Hampshire. It's a small department that all of us are affiliated or have been affiliated with at one time as well. And so it's been great to kind of connect with grad students in the greater Boston area as well. And so one of the ways that we hope to kind of continue building up this community this year is through a speaker series with peers, including just sort of informal chats around issues that impact us all. And so the goal of this is to essentially grow the peer network and kind of have regular events along this same theme and just keep discussing the issues that are important to us. And so we're really happy to kick off the series with Hannah Margolis, who's a PhD student at MIT and has done a lot of really amazing things, both research-wise and sort of mentorship and outreach focused. So Hannah and I overlapped for 1 year at Dartmouth, where she graduated from in 2020 as an undergraduate. So both of us love the chemistry of proteins and also loved the formerly existing physical sciences library at Dartmouth. I saw Hannah all the time there. It sadly closed a couple of years ago, which was so very sad, but it will always live on in the hearts of those that loved spending time there and studying there. Yeah, truly, I miss Kresge every day. And so Hannah's now a graduate student at MIT, like I mentioned. She works in Rebecca Lameson's lab studying the biochemistry and cellular biology of host pathogen interactions, and recently founded her nonprofit organization focused on virtual mentorship called Symbiotic STEM. She also writes science articles about the coronavirus and viruses in general. And this particular passion of hers has also led her to writing a children's book about viruses. So she's done a lot of different things. Hopefully we can have a great discussion about all the research work that she's done, as well as some of the extracurricular things that she's involved with too. So yeah, thank you so much for being here, Hannah. And I would love to kind of kick off the discussion with more of a research focus. So I know that you grew up in rural Nevada and kind of got your research career started independently by yourself in biochemistry. And so I'm curious to know what sort of piqued your initial interest in biochemistry and how you got started doing independent research.
So I got interested in molecular biology first, through Molecular Biology of the Cell by Bruce Alberts. I actually met him in summer of 2021 when I was in San Francisco because he's still a
No way.
professor. And it was like the highlight of my life. Like I have a picture that I took with him and I'm pretty sure I'm like sobbing in the picture. It's just really amazing. I just really love that textbook. But yeah, I took my first biology class. And up until then, like our science classes were really just all physical science.
Mm,
Um, and I just thought this stuff was super cool. And I got really interested in proteins and thinking about like aging and longevity. And I wanted to do like a science fair project on it. And I didn't know a whole lot about proteins, and we weren't
mm,
going that in depth in class. And my teacher had this big gray Molecular Biology, the Cell Fourth Edition textbook on his
mm.
shelf for when he was in college. And I was like, hey, like, is that a good book? Like, can I borrow it? And he's like, oh yeah, sure, it's great. And I started reading it, and like that was really just the end. And I really loved it. So I just kind of kept going from there.
Fair enough. So, yeah, what kind of like, I know you did kind of formulate your own research projects back then. What did that entail exactly?
Well, first of all, they all went terribly because it turns out that you can't really like Steve Jobs together biochemistry projects in your garage. It just is not really completely possible. So my mom and stepdad both taught at our little community college there, which didn't really have like research capabilities,
Mm,
but like it did have some really old equipment. They're geologists. Well, my
okay.
stepdad's a physicist. Anyway, not biology. And so I tried to do some initial projects with like things that you could buy at the grocery store, like yeast. And we had a stove with like it was a propane stove, so it had like flames, so like you could like sterilize things in it. Um, and like there was a really old centrifuge that our community college had that was like this big gray egg-shaped thing that like you had
Oh,
to
wow.
stop by like, you know, like putting your finger on it to like slow it down. So I tried to do some stuff with that and like sending samples away to get them to get a Western blot done on them. I initially tried to go to University of Nevada, Reno, which was 4 hours away where my dad lived,
Oh,
to
wow.
work on it. But I like stayed there for a week and like tried to do this Western blot, but like it didn't really end up working out. And then like the student I'd been working with was like having some issues with her own PhD. And then like they just kind of were like, we can't keep working on this with you, unfortunately. And then I
Mhm.
was kind of devastated and sent the samples off. So
Yeah, gotcha. I have some questions eventually about sort of like more in depth how that all went and if any of that is kind of incorporated into your current mentorship work. But I first just want to ask you if you could also walk us through the research you got involved with in undergrad and a little bit on what you're currently working on now in grad school.
yeah, I'd love to. And also definitely people should interrupt me if they have questions. I think I have a tendency to talk a lot, so I apologize.
Yeah, no, you're good. And I, yeah, definitely forgot to say that. But,
Oh no,
I
it's fine.
have some questions that I want to ask Hannah and just kind of like get a general sense of like her background and interest. But if anyone has any input on the topics we discussed, like either just unmute and interrupt us or send something in the chat. I'll be watching and I can read it out loud too. So yeah, feel free to just jump in. We want this to be like informal and just kind of a good discussion. So thank you for saying that. And please continue.
Oh yeah, of course. Yeah. So I the first research that I got involved in was in structural biology, and that was just kind of by serendipity. But I'd been very fascinated by proteins, and so when I found out that you could like actually figure out what they looked like, I thought that was pretty amazing. So when I got to undergrad, I wasn't quite sure if I wanted to keep doing that. I ended up first working in like biomedical engineering lab at Thayer. And I learned that I'm really not good at building things. I like to test them. And so after my first year there, I started thinking about extracrystallography because that's what I'd done a little bit before undergrad in my first research experience. I came across Mike Ragus's lab when I was looking for structural biology labs because it hadn't occurred to me to look in the chemistry department for a potential lab. I'd been looking
Mhm.
in biology. So I contacted Mike, and he was just like super sweet from the beginning. Like he invited me to come, like he wanted to hear about some project ideas. And I started working on some stuff there. And then one day he called me into his office and he was like, I have this idea for this project and it's either going to be amazing or we're going to be scooped. And I was like, okay, Mike, what is it? And so he wanted us to solve the structure of a region of one of the autophagy proteins. So they
Uh-huh.
study autophagy, which is the process of degrading damaged cellular materials.
Mm.
And there's this protein called ATG11 that's like kind of the scaffold that links what you're going to degrade to the rest of the machinery. And it wasn't quite clear how that happened. And there was like this region of that protein that we thought might be kind of like the switch that allows it to happen, and we didn't know what it looked like.
Mm.
And so that was the project. And during the course of working on it, people saw, so this was in yeast, people started figuring out the structure of part of the mammalian homologue, and like they figured out like the N terminus and the C terminus, and I was working on the middle, and I was just like nervously watching them enclosing from like both sides. But it worked out. So that was what I worked on in undergrad. And then coming to graduate school, I think like a lot of people, I was interested in pathogenesis and infectious disease a bit more than maybe beforehand. And when I rotated in the lab that I've currently joined in Rebecca Lameson's lab, I first of all just really liked all of the people. And in between undergrad and coming here, I had a really terrible research experience at the NIH. And it made me really appreciate Mike Ragusa, and made me think very hard about what I wanted in a mentor. And so that was, I think, my biggest concern was like I was kind of picking myself up, because when I started graduate school, I was very disenchanted with science at that point. And so I kind of like told myself like, give yourself a year because you got in. So like do your classes, pick a lab, and if like you're still completely disinterested, then you can leave.
Mhm.
And so I just really loved the lab and the people, and that was the main reason that I wanted to stay. But they study the biology of rickettsial diseases. So these are tick-borne pathogens. They're bacteria. They're obligate intracellular bacteria, and they cause things like Rocky Mountain spotted fever, and other spotted fevers, and then other rickettsia that are in the typhus group cause typhus, which is a very devastating louse-borne disease that was especially important in like World War II and continues to be important during like periods of famine and like for people in crowded conditions where it's difficult to wash clothing. So like war and like migrations and things like that. And these are super weird organisms. They're closely related or fairly closely related to mitochondria and have very reduced genomes. And they do weird things. And their proteins are super weird. So like a huge percentage of the genome is like completely hypothetical. And if you run it through like AlphaFold and all of these prediction softwares, it has no clue what to do with them at all. Like nothing comes back. And so that's super, that to me from a protein standpoint, that was just super cool. And because rickettsia are obligate intracellular, they're very hard to work with. Like you can't just grow them. You have to like have them in infected monolayers, and like if you look at them too long, they just die, and it's really hard. And so it seemed like a logical thing to like study the protein separately. And so when I joined the lab, one of the graduate students had come up with a new way of trying to identify the proteins that this pathogen secretes into the host cell to cause pathogenesis. And a bunch of them were like this. There was like no predicted homology or function or anything. And so they kind of wanted to do some biochemistry to start like trying to purify the proteins, get antibodies made against them, to try to like figure out what they were doing. And so that seemed like a pretty cool thing to do. So that is what I have been working on.
That's absolutely fascinating. And like, as you said, pertinent for, you know, the times today. I can see kind of how your interest got piqued in that. I did want to ask about a comment that you made about, you know, the qualities you were looking for in a mentor. So like you do a lot of mentorship work yourself, and I know have been throughout, you know, when you were here at Dartmouth and have continued to do that in graduate school. And so I wanted to ask you, like, what qualities do you look for when seeking out a mentor, either you know, like personally or professionally? And I don't know, like, are these qualities you try to embody yourself when working with the students that you work with?
Yeah, for sure. I mean, I think a lot of it is common sense, but at the same time, like you kind of have to stop to really consciously look for it. And I think from my experiences, the number one thing that matters to me that I think a mentor should do is the student should be a priority and seen as a peer. So I think some of the worst like mentorship experiences I've had on my end, where I've been mentored by people that have been awful, have been people who really just wanted someone for labor, like
Sure.
will either say directly or indirectly that I am not worth their time, and that they don't see it, you know, their job to help teach me or advance me, and like they just kind of see me as a trainee. Whereas like some of the best mentors and some of the best like teachers I've had are teachers that think, you know, like even though you're a beginner, it doesn't mean that you're dumb or that you can't participate in a very meaningful way in the field. And so being included and encouraged to like, you know, use the skills and knowledge that you have to think about advanced problems, rather than just being like, oh no, you're just learning the basics, like don't even think about that, has always been, I think, very important to me.
Sure.
And so I think like, especially like as an undergrad at Dartmouth, I was the only undergrad for most of the time I was there in my lab. And Mike was always super supportive and most of the people were supportive. But there was definitely like a weird power dynamic in being like an undergrad trying to do a lot of research. And like I tried to do lab chores to kind of like offset any of like I don't know, feelings that I was taking a lot of resources without giving them. But like I think at the end of the day, it still caused like some like power imbalances that were difficult to overcome. And like I had run-ins with, you know, Mike over this because like this type of thing happens. And like ultimately what really made me respect him as a mentor was like, even though I felt like there were like, you know, some slip ups and some things that went wrong, at the end of the day, like even if it was like months later, we would like reconvene and kind of readdress the issues. And he was always open to seeing that, you know, maybe he had been wrong or could have handled it differently. And like wanted, like didn't want to make anybody feel like less of a priority. So I think like that fine tuning and trying to, you know, work together to learn from each other is really the most important thing.
Yeah, I'm really sorry you've had the crappy mentor experiences that you have had, and glad that I don't know, Mike is an awesome person, or seems like one, and I'm glad was willing to work with you, and hopefully that's the experience you currently have in graduate school too. How do you like, I know personally, like confidence is something I've struggled a lot with in graduate school. I think lots of us struggle with imposter syndrome, and it seems like it's something that kind of disproportionately affects like women and gender minorities in the sciences, no less. And so if you had advice for kind of how to go about like approaching the conversation with a mentor of, as you said, you know, being seen more as a peer, or like, you know, I feel like there's this power imbalance and I'd like to work towards kind of solving this. I don't know, do you have any thoughts or advice on that?
Yeah, I think it's something that I think about a lot. And it's interesting because I run this mentoring group with some high school students from my old high school in Nevada. And usually there's like a common pattern where I introduce them to the mentors. And then at some point they start panicking that they're worried they're going to ask bad questions, or like they feel very intimidated by what these, like, you know, because some of the mentors are undergraduates, so only a few years older than them. And so I think they really admire how much they've grown in a few years, but they also don't feel like they're ever going to get there, or that they know enough. And a lot of them have worked really hard already, and they just like, they can't believe that there's like, you know, so much more to go up. And so I think, you know, like normally at that point, like the conversation that I've had to have with the mentees is kind of like partially that stereotypical, everybody goes through this. But also I think it's really helped to like tell them like, hey, like the mentors are contacting me because they're worried too, that like they're gonna like answer a question wrong or do these things. And so like, you guys are really learning from each other. So like you're trying to grow to become like the mentors, but the mentors are trying to grow as mentors. So everybody is working on this. And so I think, you know, like that's always been helpful, as has just, you know, like reminders that like, you know, like all we can ever do in science is try to be better, or just as humans in general. Like you have to start somewhere and you just have to keep improving, and that's never going to end. So like, I guess I personally always try, and like this is easier said than done, but like to think about like, okay, like, you know, like what's the next thing that I can do to kind of try to become a better scientist, and like what have I already done? And like, you know, everybody has to start there, like some sort of beginning. And so that's okay. And I think like one of my favorites is, so I really love Carl Sagan, and it was just Carl Sagan Day, so this is appropriate. But he has this like comment in one of his books about how like, you know, normally like if you're reading a textbook, you don't turn the next page over and go like, oh my gosh, it's so frustrating, there's even more stuff that the world knows that I don't know. Like maybe you're like, oh gosh, more, but like it should be kind of exciting too. And so if it's not kind of exciting and like a good apprehension, then like that could be the sign that like, you know, the relationship that you have with the science or with the people that are doing the science with you isn't good. Like it should be like, you know, maybe scary because you're trying to grow, but like it should be like an exciting scary where you can see where you're going to go and how you're going to be better. It shouldn't just be like an overwhelming I'm not good enough. And if
Yeah.
it is, like, there is a power imbalance, and like that should be addressed.
Yeah, definitely. I think like I don't know, kind of one way to get rid of that is just talking about it and admitting that you know, we don't know everything as scientists, as you just did. So you're a real one for you know, kind of discussing that. Thank you so much. It brought another question to mind about how, like, I think you have a lot of experience with your you know, your mentorship program that you're working with some of your old high school classmates in Nevada, or maybe it's with current high schoolers in from your high school in Nevada. I'm not sure. Okay, it's that one. But yeah, I know that's something you've kind of been working on for a long time now, but I think you're now in graduate school and have kind of made a little bit of a transition to sort of a different mentorship style, namely being a graduate student mentor to undergraduates, you know, working in your lab potentially, or as a teaching assistant, right? And I think that's a really nerve-wracking thing for graduate students who are like first starting graduate school, and you know, knowing that you just, you know, maybe you just graduated undergrad and like I've really just learned this information yourself, and now you need to go and turn around and teach it to other undergraduates as if you're a kind of expert. And I know there's at least one person here who's going to be a graduate teaching assistant for the first time in just a couple of months. And so, like, I don't know, have you found that the mentorship aspect from graduate school has changed a lot from your like previous mentorship experiences? And are there like unique challenges to that you found?
Yeah, I should caveat this with the fact that I'm starting my first TAing as a graduate student next term.
Oh, okay.
So I
Very
haven't done it
exciting.
yet, but I've already started to be apprehensive watching people who are currently doing it during the semester. And so yeah, I think the main thing already is that the mentoring that I was doing beforehand was more just in general about like different types of science, getting into
Mhm.
STEM, exploring these topics. And so it's not like helping to teach information and really needing to have every single fact right, and like
Yeah.
people writing things down and potentially using that on an exam and worrying about like their grades and things like that. So yeah, I think it's a different level of like, rather than focusing so much on like, you know, like the broader picture, you have to really go narrow, which is what classes are for, but also, you know, not always great for everyone.
Yeah, and good luck to you and your like, I don't know, your TAing next semester. I hope it goes well and you really enjoy it. Um, I feel like sometimes it can be hard to like explaining something to undergraduates in a way that like, you know, they're going to learn more about the topic later, but you kind of have to let them be okay with like, you know, promise everything I'm telling you is true, and you'll learn more about like the why and reasoning behind that when you take more advanced classes. And I don't know, that can be uniquely challenging sometimes too. In addition to just like the amount of people that you're in charge of, it can sometimes be a little bit overwhelming. But I think like you were saying, just being honest and you know, about the fact that like we're peers, and you know, I don't necessarily have all of the answers. I will do my best with what I do know, is something that's really important.
Mhm.
And I feel like, okay, we've kind of alluded to your like mentoring throughout this entire discussion. So can you tell us about your current nonprofit, Symbiotic STEM, and what the mentoring looks like? I know that I've really come to appreciate the virtual events and meetings that have kind of come out of you know, the more recent years. And so I know that there's like a virtual aspect to this nonprofit. And so yeah, if you could touch on that too, that would be really wonderful.
Yeah, for sure. And also just as a shameless plug, we are always recruiting mentors. And so I might share a flyer afterwards, but we're currently doing a round of the program. And like we just had
Yes.
our first mentoring session. So like we have like until through like December where we're gonna have mentoring sessions with my old high school. And it would be great. These are students who are for 3 or 4 hours, depending on which direction you go, by car from the nearest university. And like for example, I came from there. I had parents and a stepfather who have a PhD, and like I ended up minoring in something at Dartmouth that I didn't even know existed as a high school student. I had never heard of like biological anthropology as a science, and like that was my minor. So really means a lot to them to hear from diverse scientists and get to talk about things, because a lot of them are female, a lot of them
Sure.
are Hispanic, speaks English as a second language, like, you know, aren't quite sure they'd be first gen college students, things like that. So it's really great for them to hear from other people who've gone through similar things. And I think that is that idea of being able to talk to people who have gone through similar things is the main thing that made me want to start this organization. So I think like it's pretty common sense and like well understood that like one of the best ways to help keep people in STEM is to make them feel welcome. And one of the best ways to make them feel welcome is to give them the resources and peers that they need to overcome, you know, whatever challenges they have, just based on, you know, where they come from, or what they've experienced before. And so, for example, like, I don't know, for me to be like when I was applying even to undergrad colleges, like a lot of people that I talked to couldn't possibly fathom what I meant when I said that like I couldn't just go to a university after school to do science. I was like, it would be, I was like, it's 3 hours by car. Like there is no university to go do science. And so that just like wasn't helpful advice for me. And like the people didn't mean to not be helpful, but like they just didn't understand what I'd been through. And similarly, like I get contacted by international students a lot who are like, oh, I want to come to the US for undergrad or graduate school. And like, I can't speak to that a whole lot because I'm lucky enough to have been born here. So I'm like, oh, well, like my partner is from Mexico. Like maybe like, you know, he can talk to you about like what that was like for him, or like, you know, like I've been fortunate enough to work with a variety of people, and it's always been super amazing when like somebody will reach out to me and be like, oh, like, you know, like I recently had a student reach out to me from rural India, who was interested in coming to the US for undergrad. And I was like, oh, you know what? Like back when I was in high school, the first lab I worked in, there was a master's student there who was from India. And like, I'm going to contact him. And he was really happy to talk to this person. And so they got to talk, and it was like very relevant. And I think hopefully helpful and encouraging for both of them. So that's really the goal. And you are right, there's a major virtual aspect. And that is because I think a lot of mentoring organizations, for obvious reasons, tend to hit students that are in rural areas. So like if you have a mentoring nonprofit that does you know, local work, and even if maybe you're working with inner city students who still tend to be underrepresented and can use that mentorship, you're still going to miss a lot of people who are just too far from a city to ever have those opportunities. And I think everybody at Dartmouth really knows what that's like. So if you go like 30 minutes outside of Dartmouth's campus and you leave the Dartmouth bubble, it's really shocking the state that those school districts are in. And like those aren't even far. So like just like, you know, these people in these areas become very isolated and just kind of need help to show what resources are there and kind of draw people in. And so in terms of how the mentoring works, we're still figuring that out. So if you join the program, bear with us and please give me ideas, because it's been a struggle. Because on one hand, we want to try to provide face-to-face mentoring, like we're talking on video right now, because a lot of people find that very engaging. But at the same time, a lot of these places have very poor internet connectivity. And so like last week we had our first mentoring event, and it all went to crap because the internet connection was just too slow and students tried to log in on their phones, and then a lot of them couldn't unmute themselves. So it was just, you know, and like we only had a 55-minute class period to do this. So like it was just a pain. And so, and we've tried doing like more text-based communication, like using Slack. And a lot of students, some students really liked it, but a lot of them found it to be, you know, too disengaging because it wasn't synchronous communication and you couldn't see each other. So we're still figuring it out. But the main goal right now is kind of just to have this platform where interested mentors, such as yourselves, and it can be anybody with any kind of experience from like undergraduate students through PIs, can make a profile. And basically what I ask in the forum is if the mentors can share any personal information about themselves and their identity they're willing to, because that can help the mentees find someone they relate to. So like, for example, I know that in this high school class that I'm working with right now, there are a few students who are on the autistic spectrum, and they saw that a few of the mentors had chosen to indicate that they were also on the autistic spectrum, and they were super excited to get to talk to someone who would, you know, like had that background and had made it in science and had been able to use that as a benefit to who they were. And so that's really the idea right now. And then the high school teachers can use this database of mentors that we give them to kind of help their students reach out to these mentors, and do, like mentoring events, kind of like big online mixers, or have the mentors and mentees kind of connect one-on-one. And so we're trying to make it as flexible as possible so teachers can use it under the, I think, very correct assumption that they know what their students need better than I do. But at the same time, we don't want it to be too flexible because we want the teachers to not be more overwhelmed than they probably already are. So it's been difficult to kind of find that happy medium, and I think we're still working on it.
Yeah, no, your mission is amazing. And, you touched on the aspect of just representation being so important, especially in bridging that gap between the primary and secondary education, and the turning point of deciding is the science research, something I'm interested in enough to pursue in higher education. And so I think it's really wonderful work that you're doing. I did, New England GWiSE put out a flyer this week with your Symbiotic STEM kind of flyer in there. So that's been put out into the universe. I will also share the flyer with those of you attending the event today in case anyone's interested in being a mentor. But yeah, there was a lot of great stuff in that. I think especially, just touching on the aspect of the transition to undergrad and starting research and realizing that a lot of people do come in having science experience from high school, or their parents were both professors or scientists. It's so common. And I don't know, I also had a very abrupt transition from high school to undergrad. I was low income and came in on a Pell Grant, and would have appreciated some, I don't know, just program where I could either maybe connect with other students who are in the same position as me, or a more formal path of seeking mentorship for students that have had similar experiences to mine. And so I think what you're doing is really important for that reason. And I don't know if anyone else is here can relate, definitely feel free to jump in, because I'd love to hear your experiences as well. But if not, I would love to ask you, Hannah, if I don't know, if you have any thoughts about how to maybe implement something like that on the undergraduate level to kind of help with that transition, maybe, because I think that's something that impacts a lot of I don't know, students that are interested in science. And I think there's a wide interest base when you start off in college, but the numbers of, especially underrepresented minorities in science, they just dwindle as you get kind of higher up on the academic ladder. And I think a place that would be really important to start would be kind of with the undergraduate transition. So I don't know if you have any thoughts on anything that could be implemented in the undergraduate level, but you have so much experience kind of in that arena. So I figured it'd be nice to hear your thoughts.
Yeah, I'm not sure. I mean, I think one thing that comes to mind that I've thought would be, really good to implement, and I don't know how one would do this, is kind of a ladder mentoring approach, right? Where it's kind of mentoring all the way down.
Yeah.
So if you have mentors in an organization like ours, where you have everyone from undergraduates through professors, they should be talking to each other too.
Mm-hmm.
And hopefully, because these are people who are choosing to volunteer as mentors, they likely relate to some of these backgrounds, and can reach out to each other. I think that would be very helpful. But I mean, I think there's more, which is something that we're also all probably very familiar with, which is that we talk about the leaky pipeline in STEM, and it's more I don't think these people are just dropping off, they are being pushed out.
Mm-hmm.
It's an active thing caused by negligence in the STEM system across universities. And so I don't know, even just the fact that when I took my undergrad courses, the only class that I ever had to go into even a little bit about the really dark, crappy recent history of STEM and what it's done to marginalized groups, and why that makes it important to have these conversations was my anthropology class. And that was part of the reason I was so impressed by it, was that I never had a science class be like, oh, hey, like while we're talking about, you know, like genetics, we should talk about how this has gone wrong very recently and is continuing to today, and like what that means. And like, so I think that's really big, because a lot of people are just, you know, feel scared and unwelcome for obvious reasons. And also, you know, like all of these findings just again and again find that people in these, you know, underrepresented positions, they aren't leaving because like, you know, it's hard, or, you know, like they just were worried coming in or anything like that. They feel unwelcome. They feel that they are actively being, you know, not treated fairly, not treated right. And just like every day is harder for them than it should be. And so, you know, I don't know a great solution to that other than to try to, from a beginning level, teach people to be better, decent human beings, and help them to find people that they relate to, so that people don't feel that they don't belong. So like, I don't know, a lot of people on this call probably already know about this organization, 500 Queer Scientists. We heard a talk from the founder last week here, from our one of our bio LGBTQIA groups, and it was amazing. And so like just this idea of like trying to help people find people with similar stories, to kind of bring these things into the mainstream, is really important. And I think the pandemic did a lot of work for it. I know that like our like department head here in biology, like, and like the graduate officer professors who like oversee the graduate program, felt like my year, like we came in 2021, so right after the pandemic, they felt that like there was a radical shift in expectations compared to the year before. And I think that's a really good thing. So like, I think the admin have been continually rather uncomfortable around a lot of these conversations that are being brought up. And then, you know, things like we've unionized. I saw you guys just started launching your graduate union. So yay.
Yeah, we're trying. Yeah.
Yeah. So, I mean, I think things like that really kind of create some checks and balances, try to make changes in areas that maybe, you know, people who are more established aren't willing or feel uncomfortable doing, is really like what's most important for kind of trying to make this all more welcoming. Like obviously you just need more voices, and if, you know, like in a lot of these institutions, if it's not easy to get your foot in the door to have that voice, then like you need a union, or you need these other ways to force people to have to listen to you basically and make the changes if they're not willing to.
Yeah, absolutely. And I don't know, I just think like that's one of the reasons why I'm trying to like implement this whole series, is just like a grad school can feel really isolating, and undergrad can too, if you're you know, coming from a background that feels really dissimilar to a lot of your peers. And so it's really nice knowing that like you're just not alone, and you've shared experiences with a lot of people that are going through the same things as you. And so it's really nice to see that your like graduate class is really making an effort to affect change at MIT. And I don't know, hopefully we start to see the changes across the board in academia, like, I don't know, like moving a little bit higher up the ladder, right? Like it really, like I know for women in STEM, it's like seeing the equitable representation all the way up to the professor level is just like really abysmal, and we're not there yet. And of course, that's numbers even lower for women of color. And I think it's nice to see that, like, I don't know, we all just care about all these issues so much, and are hopefully working towards making that change. I wanted to ask as well, like, you know, kind of starting from the beginner level, you're like, you know, mentoring is primarily focused on high school students. How do you like get them interested in science in the first place? And I don't know, like, do you feel like the way that we introduce science at the high school level like is sufficient currently? I don't know if that's the best way to word it, but like, yeah, how do you get them to see that like science is cool and anyone can do it if you like it enough?
Yeah, I think this is another issue of not so much a leaky pipeline as forcing people out from a very early level. Because I definitely, like, I remember talking with, like, you know, elementary students in my hometown who are like very gung-ho about science, and by the time you get to high school, it's all crapped out. And so I keep thinking about the fact that, like, so I was in high school in this rural place in Nevada, and like I was incredibly frustrated and alone and isolated because I wanted to do biochemistry and there was no biochemistry that I could do. But there was really good science going on there. Like we have like some of the biggest gold corporations in the world. There's amazing geology. Like that's why my parents moved there. And there's also quite a lot of wildlife. Um, and so, you know, like there are all sorts of like ecology and geology related fields. And like I just never could figure out how to find them. Like, you know, like there must have been researchers traveling in and doing that. And so I really think like, you know, when we engaged high school students, when I was at Dartmouth and I had my mentoring program there, one of the most successful things was, you know, trying to relate it to what the students were doing, which again seems very obvious, but it takes going beyond just like the cookie cutter, you know, curriculum. And so, you know, like it would be really great if people could see the way that like where they live is contributing to scientific understanding and to like get to, you know, see science in their own terms rather than being told like, no, like your way of thinking about science is wrong. Like this is the way that scientists actually do science. Like, fortunately, that's becoming kind of an outdated opinion, but I mean, like Dartmouth was kind of founded to like assimilate people. And so like this idea of like still this process of like, no, like everything you know isn't actually science. That's not how science works. Like this is science. It is really awful. And so I think, you know, trying to work with these students to kind of come up with like, you know, like pie in the sky, like what kind of scientific questions do you think about, either based on where you are or just like out of general interest. And like, even if you can't actually do those experiments now, like how would you start to think about going about them? And like, you know, like where would you want to go next to allow you to kind of start to answer them? Like, I think that kind of engagement can be huge. And I really like something that I really wish I could do that I'm thinking about trying to do with Symbiotic STEM is something kind of like that, where it's like, you know, if you like a log of kind of scientists that are doing field work in these remote areas, if they could be able to be put in contact with local schools to take the students to see the work that they do where they live. Because I think a lot of these students, like it would be really cool if nothing else for them to get to see that. Because again, like the goal shouldn't just be getting everybody into science, because like there are fields that are not science. And I mean that as a compliment, because science is not perfect and science is very flawed in a lot of ways. And so we need complementary fields that, you know, take care of that stuff. And so I think it's just kind of down to showing students how science works, teaching them the critical thinking skills, you know, making sure that next time that there's a pandemic, because it'll probably happen again, that like there's more, you know, just like basic scientific knowledge of like how viruses work and what they are, and like what common, like, you know, like why soap and water is effective for, you know, denaturing the viral protein coat, like, you know, just like things like that. I think, and like having like that healthy dose of like skepticism taught you is just like really important. So like that kind of level of scientific teaching on the high school level, I think could definitely be helped by trying to engage students with like what is around them rather than forcing outside things in.
Definitely. And I would love for you to like touch on the communication aspect of your work, because I know that you do a lot of that as well. So would you be able to tell us a little bit about the articles that you've written in the children's book, and how you go about adapting your science communication style from like what you might do on a daily basis, trying to write for other professionals in your field or for journals, to either non-professionals or, you know, all the way down to the level of children?
I guess like the main thing is I don't know if I'm doing it right, because I haven't been doing it for that long. But I guess the way that
just
I
about
do
your
it,
experience.
yeah. I mean, the way that I've tried to do it for okay, so like for example, when I started writing these articles for my hometown, it was at the start of the pandemic, and it was based on the fact that, so this is a very right-wing Trump supporting area.
Gotcha.
Like when I was in high school there, somebody put up like a vote for Bernie sign. I don't even know who put that up, but like there were bullet holes in it by the next day. So like this is like a very radical place. And so when the pandemic hit, before all of the anti-science nonsense started, a lot of these people who I'd known growing up, who had this kind of political background, they had a lot of questions, and they were like legitimate questions about like, you know, like why is this actually different than like the flu or the common cold, and like why can't we use antibiotics to treat it, and like why are masks sufficient if viruses are so much smaller than, you know, like the particles that can make up a mask, like how is that then working? And so I think the main thing that made that like helped guide me in how to write them was like kind of I would scroll through like the like local newspapers like Facebook page and look at like the comments that people were posting and kind of take out the expletives and like see what like it boiled down to the question being. And a lot of it was like a lot of anger around like, oh, like they're trying to make us wear these masks and they clearly won't work, and kind of taking their misconceptions and trying to put them into like something that maybe like I could scientifically break down in a simple manner.
Yeah.
And so I think it was kind of about trying to answer those questions from a basic level that I knew people wanted to have the answers to because they were asking them. And so I think that's kind of how it all started, and just like trying to focus on like one big thing per article. So like one of the articles was like, how do masks actually work? And so kind of talking about like, let's talk about, because like there's a lot of misconception about scales of things. So like people didn't understand why like if you could smell something through a mask, viruses couldn't necessarily get through. So kind of like actually talking about what is the scale of like something that you smell in terms of like atomic size versus a virus versus like the way that a lot of things are carried in respiratory droplets, and like what about like distance and the way that like kinetic energy is going to cause things to slow down the farther they get from you. And so like just kind of talking in very basic terms to kind of try to reason with people, I think was the main thing. And it was a fun thought exercise. So
yeah, I feel like I don't know, like when trying to communicate science to people who like are maybe like non-experts or like not as far along in the trajectory, like for an undergrad, for example, I don't know, like I always find that I learn a little bit as well, even just through the process of like explaining it or writing about it, which is always really cool. But yeah, have you like, it sounds like the topic is pretty much, it's like viruses primarily related to COVID, and have you gotten a lot of pushback like from these articles? And like, I don't know, has it been tricky to deal with that aspect of things, or has it been kind of received mostly positively?
the articles themselves have been okay. I think it helped a little bit because a lot of the people who are like a lot of them were people who I knew or who knew me from when I was younger and I was in high school there.
Sure.
So I think it was helpful that they could see me as like someone who like, okay, maybe like I was like clearly like a more I don't know why science is political, but why like I was more, they saw me as more of a liberal person.
Yeah.
And like like pushing kind of like these facts about science that maybe like some of their news programs were saying were false or were politically motivated. And like if they knew that I had seemed like a decent person when they knew me, maybe they'd be more inclined to believe me to begin with, or like to listen. So I think that was part of it. I did get more pushback. Like occasionally I would kind of like get into like Facebook arguments with people on like the Elko Daily Free Press, like social media platform, when like they post a story about, like something about COVID, and somebody would post something just like completely ridiculous. Like I would just kind of feel the need to try to say something. And I got into some weird arguments with people that like sometimes you just like, there wasn't an argument to come back with. Like it just like what was being said just like didn't quite make sense, and there was no way to meet halfway. But I think that was the main thing. I had like one really strange instance of like some research that I had done in high school, like somebody trying to use it as an example of why Trump's idea of drinking bleach wasn't wrong, or like I'm probably misconstruing that, so I apologize, but like it was something along those lines, and it was very confusing to me. And so I think like a lot of it came down to like trying to ask people questions. And I think like like that's the main thing, is like I'm trying to understand like what they're thinking, and it's just that like sometimes they don't want to talk about what they're thinking, or like they just like that's the end, like what they say is like where the like the whole thing stops. And so like in that case, like you just got to move on. But I think like the only successful conversations I ever had about those things were when people were willing to like actually answer questions and ask questions back, and then like maybe you could kind of break down like these like misconceptions and kind of get out what like the actual underlying question was, and like pull that back up to the surface, if that makes sense.
Yeah, no, it does. Yeah, that sounds absolutely crazy. And I especially like using you said it was your research you did like independently in high school, right? Like yeah, that's like, I don't know, just using a high schooler's research to try to prove something so crazy.
Yeah, it was interesting
to me. Are you like how do I want to word this? Did you attend grad school with like a certain career path in mind? Like, are you looking to go in, like are you looking to incorporate science communication or science policy into your future career plans? And like, since you're doing a lot of that sort of thing now, or are you thinking of taking a different path with your?
I don't know, it changes a lot. I think like a lot of people can probably relate to. And I think also maybe like a lot of people, when I came into undergrad, I was like, yeah, I'll be a PI one day, and like I want to make sure I have a desk that's specifically for high school students, so like, you know, like somebody can always have that desk and like, you know, get to be included in science. And then like I don't know, the more like, so my partner is a postdoc here, and like I see that he doesn't make a whole lot more than me, and then like his PI doesn't make a whole lot more than him, and I'm like, okay, like, you know, there's a point where it stops being noble to work a lot and not be able to like live. So I think it's something that, you know, like is a major reckoning happening in science overall anyway. So yeah, I'm not completely sure. I think I like infectious disease a lot as a research topic because I feel like you can take it in a lot of directions. And I think it's a field that naturally has some science communication built in. Because if you're, you know, trying to get people to take preventative measures and things like that, it like they'll be much more effective if you can explain to them the science of why you're asking them to like take these interventions. From like an epidemiological standpoint. But I also really, I grew up on a ranch. I love animals. And I would really like, we use a lot of science for people, which is great, but like animals get sick too. And like, we, you know, like need to study them and help them. And so I think like the idea of, like I keep like going to the aquarium to like look at the penguins here in Boston and like just like wanting to just like be like, maybe I'll just like go help keep the penguins healthy and I just don't need a graduate degree. So like it's a debate that keeps coming up. But yeah, I ideally I think like if I become a PI in the end, I would want it to be somewhere where there is a focus on undergraduate teaching.
Sure.
I don't really fully understand the rat race of like trying to like get these publications and be the best in the field, and that just sounds like incredibly stressful and awful. And like for what? So
Yeah, absolutely. Well, I'm sure you have so many passions, and I know you'll bring them into whatever career you end up going into after graduating with your PhD. So, yeah, hopefully we'll get to stay in touch and we'll get to see where you go. But yeah, I think that kind of for me wraps up the interview portion of this call. I wanted to see if anyone else that was logged in had any questions for Hannah or wanted to like start a discussion about any of the many topics that she kind of touched on today. Feel free to chat things too.
Hi, Hannah. Thank you so much for sharing your story. And it's nice to like hear what you're doing now at MIT. I was always like inspired by you here with like many mentors, now seeing like Symbiotic STEM. So yeah, thank you so much. I think my comment for you is, are you considering science policy potentially as a career path? Not to project onto you, I'm very interested in going into science policy, and I think based on like the outreach that you do, as well as like combining your passions with STEM, I think you would make a great career in that. Yeah, I'm just curious what your thoughts are on that.
yeah, that's really cool. I'd like to hear your thoughts on it too. But I definitely thought about it. And it's just hard to know, right? Because like I feel like so much of my life through undergrad especially was like so obsessed with research, that it was actually kind of a good reckoning when like the pandemic started and like all of a sudden I couldn't be in my lab anymore, and I really kind of thought the world would end for me, and it didn't. And like I hung out with friends and like in my little quarantine bubble, and like, you know, like actually got to like think about other things in life. And so I think like maybe it won't be as bad as I think it will if like I went into something that didn't involve working in a bench. But like where I am now, I feel like I would really miss it. But yeah, I guess like, is there, I'm curious about like for you, like is there a certain area of like science policy you're thinking?
Yeah, so right now, I'm looking into positions all over the place, but one that I'm really interested in is with Union of Concerned Scientists. They're a nonprofit, yeah. And there's this Kendall Fellowship that is dealing with like nuclear policy. The fellowship like what they're envisioning right now is dealing with populations that are affected by nuclear contamination and studying the health impacts, looking at health records, specifically looking into people who experience like miscarriages, and unfortunately like babies are being born with like birth defects because of nuclear contamination. This is actually all out in Hanford, Washington. I don't know if you're aware, like they did a whole thing of like manufacturing nuclear weapons there. And unfortunately the fallout from that, people were experiencing disease and things from the radioactivity that was coming from the waste there, because it was poorly taken care of. And it's actually called America's Chernobyl, and I didn't know about it until recently. So yeah, if you're interested, a bunch of podcasts out there, Hanford, Washington. But yeah, that's something I'm now interested in. Yeah.
Looking forward to seeing the work you do too, Aileen. Okay, does anyone else have any other questions for Hannah, or like, I don't know, any other discussions they'd like to bring up? Hopefully we can all like stay connected after this too. And hopefully Hannah will be willing to let you all reach out to her with any questions as well later. Cool, good to know. Yeah,
Thank you.
If not, please join me in thanking Hannah for coming on our platform today. And I don't know, it's just really great to continue to build the community that we have, and hopefully we can all I don't know, continue to stay connected. And I would like to implement more of these throughout this year, so hopefully it'll just continue to grow as the year progresses and beyond. Yeah, it was wonderful getting to chat with you today, and I don't know, finally get to like have a conversation with you. It never quite happened at Dartmouth, and you're really awesome. All of us here really admire you, and a lot of that comes from like your passion for all the work that you do inside and outside of the lab is so clear, and just really wonderful to see. And so you're just a great person to know and be connected with. So thank you so much for coming on here.
No, thank you so much. I'm really glad that we got to all talk. And yeah, I definitely, if any of you are interested in the mentoring or have ideas for how I can better engage the students, or are from a high school that you would like to see get connected with mentors, like definitely, like I've gotten like a number of people who've approached me about that. And I think it's like one of the best ways we can like help out more people, because it's meaningful to someone and good. So yeah, please let me know.
Yeah, and I will be sure to disseminate the Symbiotic STEM flyer in case anyone's interested in being a mentor with Hannah's nonprofit organization as well. And thanks to all of you for joining today and being a part of the discussion. So yeah, wonderful to see you all. Hopefully you have a great rest of your week. And yeah, hopefully we'll all get to see each other soon at the next event. Thank you so much. Take care, everyone.
Thank you, everyone.
Bye.